right above your head, in the ceilings of your favorite restaurants or coffee shops or, transit hubs, there are massive pieces of industrial machinery that are actively trying to tear themselves out of the roof.
Yeah, and it's wild because the only thing stopping them is this invisible war of physics playing out right there while you casually sip your latte.
Exactly. I mean, we spend so much of our lives just like looking down at our phones
Yeah.
or straight ahead at the person sitting across from us, and we completely ignore this incredibly violent architectural ecosystem floating just out of reach.
We really do. We treat ceilings like they're just, well, just a lid on a box. But there is a hidden, highly active mechanical world up there that dictates exactly how we experience the space below.
It's crazy.
It is a remarkable blind spot in how we navigate our daily environments. I mean, we expect modern commercial spaces to feel perfectly climate controlled and, aesthetically pleasing, but we rarely stop to consider the heavy engineering required to manufacture that illusion.
Right, because the space above us is rarely static.
Oh, absolutely not. It's a dynamic zone. It's all about thermomanagement, structural dampening, and hidden architecture.
Which brings us to the grounding material for today's deep dive. We are looking at a field note, which is just this really fascinating slice of observation from a photographer named Eng.
Dated July 5th, 2026.
Yes, exactly. The entry is titled Notes on Photography, Part 244, and it documents this seemingly ordinary moment. So Aang is out on a mundane grocery run, takes a break to grab food at a small restaurant, and just happens to look up.
And what Aang documents in this field note really sparks a mechanical mystery.
It totally does. And our mission today is to decode it. We are going to investigate this massive, entirely out-of-place piece of industrial machinery that Aang found operating inside this tiny shop and, uncover the invisible physical forces hiding in plain sight.
Sounds like a plan.
Okay, let's unpack this. Let's start with the visual that actually stopped Aang in their tracks. We are in a small neighborhood restaurant, but hanging from the ceiling is a full-blown HVLS fan.
Right. And for those of you listening who might not be familiar with commercial HVAC acronyms, that stands for high volume, low speed.
High volume, low speed.
Yeah. And to appreciate why this specific visual is so jarring, we really need to establish the typical habitat of an HVLS fan. As Aang points out, referencing an earlier post from their archives, these fans are engineered for massive, cavernous spaces.
Like really massive.
Yeah, we were talking about environments with constant heavy foot traffic and massive square footage.
Yeah.
So aviation hangars, sprawling logistics centers, manufacturing plants, vast transit hubs.
Places where you expect heavy machinery.
Exactly.
Yeah.
These machines often have wingspans of up to 24 feet. They're designed to move massive columns of air across facilities where thousands of square feet need climate management.
Which makes putting one in a small restaurant feel completely, I don't know, disproportionate. Like, to put this in perspective, installing a commercial HVLS fan inside a tiny dining room is like taking the engine out of a massive commercial farming tractor and trying to shove it under the hood of a golf cart.
That is a great visual.
It just doesn't compute. Like, why on earth would a restaurant owner install this behemoth in such a tiny space? I look at this and my immediate thought is, okay, this has nothing to do with airflow.
Just an aesthetic choice, you mean?
Yeah, like a designer trying to make an edgy, industrial chic statement. It just feels like complete overkill to me.
Well, take that tractor engine analogy a step further.
Yeah.
If you put a tractor engine in a golf cart, you are optimizing for the wrong kind of power.
Right.
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 But if we look closely at Aang's field note, there is a very specific physical justification provided that changes the equation entirely.
Okay, I'm listening.
The variable that validates this massive installation is the restaurant's incredibly high ceiling.
Oh, the high ceiling.
Yes. When you introduce verticality into a small footprint, the thermodynamics of the space change drastically. Heat rises, as we all know. So in a small room with a highly elevated ceiling, you experience a phenomenon called thermal stratification.
Meaning all the hot air generated by like the kitchen, the bodies in the room, and just the summer heat outside, it all gets trapped up in that vertical space.
Exactly, creating a massive temperature imbalance. The floor where the diners are actually sitting might feel freezing because the AC is working overtime.
Oh, I've been in restaurants like that.
Right. But meanwhile, the ceiling is acting like a literal oven.
So if a restaurant uses a traditional high-speed ceiling fan in that environment,
It just frantically churns the air immediately around the blades. It creates a localized draft, perhaps cooling the people directly underneath it through evaporation on their skin. But it totally fails to address the trapped heat higher up.
I see.
A high-volume fan, on the other hand, operates on a completely different principle. Because of its massive wingspan and specialized blade design, it slowly and deliberately captures that gigantic pocket of trapped hot air at the top of the room and forces it downward in a continuous wide column.
So it's actively destratifying the air. Like it's taking the cubic volume of the entire room, going straight up to the rafters and folding it back down to the floor.
Without creating a hurricane-force wind that blows the napkins off the table.
That makes so much sense.
Yeah, it manages the vertical column of air just as effectively as it usually manages the wide, horizontal spaces of a logistics warehouse.
Wow.
By moving a massive volume of air at a very low speed, it equalizes the temperature of the entire room silently and efficiently.
Wow.
So it transforms what initially looks like a bizarre aesthetic choice into a highly sophisticated engineering solution for a really difficult architectural space.
Okay, that completely reframes how I look at this. But as I read through Ang's note, the fan itself isn't even the most intriguing part of the photograph.
No, it's not.
The narrative shifts, and Ang zeroes in on a very specific, almost strange architectural addition surrounding the machinery. There is this heavy black metal mesh frame installed completely around the fan, bolting it to the ceiling.
And the crucial detail Ang points out is that this massive fan does not technically need this frame to run.
Wait, really? It doesn't need it.
No. The motor and blades could theoretically operate completely exposed.
But the inclusion of that frame introduces like an entirely new layer of complexity. Because if the machinery functions without it, you are adding significant weight, expense, and structural load to the ceiling for a secondary purpose.
Exactly. And the text offers 3 specific reasons for this installation, starting with the visual presentation of the room itself.
Okay, appearance.
Right. The mesh is there, in part, to camouflage a messy roof design.
Which, if you think about commercial real estate with high ceilings, a messy roof is basically a guarantee. Right?
Oh, absolutely. When an architect decides to leave a ceiling exposed to make a small room feel taller, they're exposing the raw industrial reality of the building. You aren't looking at a smooth, finished surface.
You are looking at the building's internal organs.
That's a good way to put it. Exposed HVAC ducting, sprawling electrical conduits, rough plumbing, uneven insulation, structural I-beams.
It's the backstage of the restaurant.
And that backstage can be incredibly distracting for a patron trying to enjoy a meal. What's fascinating here is the modern design trend of exposing the ceiling to gain vertical space actually creates a conflict between the desired atmosphere of the room and the necessary utilities required to run it.
It's like a theater curtain.
Theater curtain.
Yeah, when you go to a play, the curtain obscures the stagehands, the lighting rigs, and all the pulleys, right?
I see where you're going.
The heavy black metal mesh acts as that curtain for the ceiling. It gives the eye a definitive, intentional endpoint. You look up, you see the sleek, industrial black frame, and it naturally obscures the chaotic, tangled mess of wires and pipes hiding just a few feet above it.
All while letting that massive volume of air pass right through the mesh.
Exactly. It provides the illusion of a finished ceiling, satisfying the aesthetic requirement of the space.
But the text quickly moves from aesthetic camouflage to a much more literal form of protection. The second reason Ang provides for the mesh frame's existence is to act as a physical safety net, catching falling roof debris.
Okay, I have to admit, when I first read that in the source material, I laughed.
You laugh.
Yeah. Catching falling roof debris. Like, are these people dining in a collapsing coal mine? The idea of a restaurant needing a literal safety net implies that chunks of the building are just raining down on the customers on a regular basis.
Well, it certainly sounds alarming when you phrase it that way. But this highlights the fundamental tension between modern interior design and the physical reality of aging commercial architecture. We tend to think of buildings as static objects, but they're constantly in motion.
Constantly in motion.
Yeah. Consider a heavily utilized commercial space, perhaps an older building retrofitted for a new restaurant. It is subjected to constant subtle vibrations from delivery trucks rumbling past on the street outside.
Oh, right.
It experiences daily temperature fluctuations that cause the metal beams and wooden joists to expand and contract.
So a building is constantly breathing and shifting. And over decades of those micro movements, things start to loosen.
Exactly. Flakes of old industrial paint let go.
Huh?
Small pieces of degraded drywall or plaster crumble. Maybe a loose screw vibrates its way out of a forgotten ventilation duct. A brittle piece of ancient insulation detaches. We're not talking about boulders of concrete crushing a table here.
We are talking about the slow, microscopic, inevitable decay of a ceiling over time.
Yeah.
But wait, If a screw or a chunk of dry plaster falls in a normal room, it just hits the floor. Maybe it lands in someone's soup, which is a bad Yelp review, but it's not a lethal threat.
True, but if you have a massive industrial fan spinning directly beneath that decaying ceiling,
Oh, wow.
the hazard multiplies exponentially. Any small piece of debris that falls from that messy roof design isn't just going to drop straight down. It is going to intersect with massive, solid metal blades.
And even though the fan is operating at a low speed, those blades carry immense kinetic energy.
They do. If a loose bolt from an HVAC duct falls and hits a blade spanning 10 feet from the center motor, that bolt is violently launched across the restaurant.
It literally becomes a kinetic projectile. Like a slow-moving fan hitting a falling piece of metal turns that metal into shrapnel.
Precisely. The black metal mesh is a literal safety net, intercepting anything falling from the ceiling before it can interact with the moving machinery below.
That is wild.
It reveals this incredible paradox in modern commercial spaces. The owners want to cultivate an industrial chic aesthetic. They want the impressive, massive factory fan spinning lazily above the dining room. But to achieve that vibe safely, they have to actively and aggressively armor the space against the literal, messy, and highly dangerous industrial reality of the building itself.
They want the look of a heavy manufacturing plant, but the safety and cleanliness of a pristine dining room.
Spot on.
So the metal mesh is protecting the aesthetic illusion just as much as it's protecting the physical safety of the customers.
Exactly right.
But here's where it gets really interesting. Because while aesthetics and debris capture the imagination, Ang explicitly notes that there's a third, far more critical reason for this heavy black frame.
Yes, the primary driver for the installation.
And this reason is cited as the most likely cause for its existence: physical stability. The frame is there to absorb heavy vibrations and twisting forces, so the massive fan won't wobble.
Which shifts our focus away from the architecture of the building and plunges us directly into the invisible physics generated by the machinery itself.
And this is the part that genuinely sent me down a rabbit hole, because we just established what HVLS stands for: high volume, low speed. The key word being low speed.
Right.
If this massive machine is lazily, slowly pushing air downward, why on earth are the vibrations and twisting forces so violent that they require a heavy metal exoskeleton bolted to the ceiling just to keep it from tearing itself apart?
It seems counterintuitive, doesn't it?
Totally. If you think about a helicopter, right? When a helicopter spins its massive rotors, the sheer rotational force makes the entire body of the aircraft want to spin in the exact opposite direction. That's why helicopters have a tail rotor, to counteract that torque and stabilize the cabin.
That's a fantastic comparison.
But are we looking at a similar aerodynamic battle happening above a plate of noodles?
The physics underlying your helicopter analogy are exactly what is happening in that restaurant. You are describing torque and rotational inertia.
Okay, torque.
To understand why a low-speed device generates such violent destructive force, we have to look at the other half of the acronym: high volume. It is easy to forget that air is a fluid.
Right.
It has mass, it has density, and it offers significant resistance.
So it's not about how fast the blades are cutting through the air, it's about how much physical mass they're attempting to displace at one time.
Exactly. Think about trying to drag a small plastic paddle through a swimming pool. You can pull it quickly with very little effort because the surface area is small. Now, imagine taking a solid wooden door and trying to drag it through that same swimming pool. Even if you walk slowly along the edge and pull it at a fraction of the speed, the resistance of the water against that massive surface area is going to require an enormous amount of physical energy.
Oh, wow. Yeah,
The water is going to push back against your arms with incredible force.
that makes perfect sense. The air in the restaurant is the water in the pool, and these massive, specialized industrial blades are the wooden doors.
When an HVLS fan motor engages, even at low revolutions per minute, it is commanding those massive blades to push tens of thousands of cubic feet of heavy, thick air downward.
That is a lot of air.
And Sir Isaac Newton's third law of motion dictates that for every action, there is an equal and opposite reaction. As the motor exerts massive energy to push the blades against the resistance of the air pushes back against the blades with equal force.
Meaning the motor is desperately trying to spin the blades, but the resistance of the air is desperately trying to spin the motor in the opposite direction.
That opposing rotational force is torque. And because this fan is suspended from the ceiling on a single mounting pole, all of that tremendous torque, along with the heavy vibrations of the motor working under load, is channeled directly up into the mounting hardware.
So if that heavy black metal frame wasn't there, all of that rotational energy would just twist the mounting pole, the fan would start to sway.
If we connect this to the bigger picture of structural engineering, a sway is the beginning of a catastrophic failure.
Right.
If a massive industrial machine begins to wobble at the end of a mounting pole, that kinetic energy doesn't dissipate, it amplifies. A small wobble hits a resonant frequency, which becomes a rhythmic, violent sway. The mounting bolts would eventually shear off and the entire assembly would tear itself out of the ceiling.
It is the ultimate display of hidden mechanics. The metal frame is a vital energy dampener. It locks the motor assembly in place, acting as a rigid exoskeleton that forces the violent kinetic energy to be managed rather than allowing it to translate into a destructive resonance.
It really is.
They have to build this heavy, reinforced cage just to tame the invisible, violent forces generated by the fan, all while the people sitting directly below it, eating their lunch, are entirely oblivious to the mechanical wrestling match happening over their heads. You just feel a nice, gentle, perfectly distratified breeze.
It is a masterful piece of over-engineering required to make our environment feel entirely effortless.
Yeah.
The frame is a structural necessity, cleverly disguised as an industrial chic aesthetic choice.
So what does this all mean? We started this deep dive with a photographer just grabbing groceries, taking a break, and having the simple curiosity to look up at the ceiling.
Just a single photo.
Right. And from that one short field note, from that single photo of an out-of-place machine, we have unpacked a masterclass in commercial engineering. We've explored how tall spaces create thermal traps that require massive, industrial-scale fluid dynamics to solve.
We really have.
We've seen how heavy metal mesh serves as a theater curtain to hide messy architecture and acts as a vital safety net to protect against the realities of decaying, shifting buildings. And perhaps most impressively, we've uncovered the violent, invisible forces of torque and resonance that have to be heavily caged and tamed just to move air slowly around a small room.
It should fundamentally alter how you perceive the built environments you inhabit every day. When you understand the forces at play, you realize that every object in a commercial space, no matter how purely decorative it may initially seem, is likely performing a highly specific, necessary function to keep the space viable.
I want you to carry this with you the next time you are sitting in a coffee shop or walking through a transit hub or waiting for a table in a neighborhood restaurant. Take a second and look up. Look past the lighting fixtures, look past the paint job, and really appreciate the invisible architectural battles being fought second by second, just to keep your environment comfortable, safe, and aesthetically pleasing.
It's all happening right above us.
There is a massive, heavy-duty world hiding in plain sight if you just know what you're looking at.
And as you look up and appreciate those hidden mechanics, I want to leave you with one final, perhaps slightly unsettling thought to consider, building on Eng's observation about stability.
Uh-oh. Unsettling.
Just a bit.
Yeah.
We established the absolute necessity of that heavy metal mesh frame. It is actively absorbing massive twisting forces and heavy vibrations to keep that industrial fan from wobbling out of control. But a foundational rule of physics is that kinetic energy does not simply disappear.
Right. It transfers. It can't just vanish.
Exactly. The frame stops the fan from moving, but that energy has to go somewhere.
Oh.
If that rigid metal exoskeleton is successfully stopping the motor from wobbling, it means it is transferring all of that heavy, violent rotational torque directly into the ceiling joists it is bolted to. It is dumping that energy into the structure of the building.
Wow.
What happens to the structural integrity of a small, older commercial building over 10, 20, or 30 years of silently absorbing the violent displacement of those industrial forces?
Could the very machine that was brilliantly designed to improve the room eventually compromise the roof it's attached to? The cure slowly becoming the cause of a totally different structural failure.
It's definitely something to think about.
That is a wild thought to leave off on. Thank you so much for joining us on this deep dive today. Keep your eyes open to the hidden mechanics of the everyday world, and never stop looking up to see what's actually holding it all together.